People with very high expectations have very low resilience. Unfortunately, resilience matters in success. I don't know how to teach it to you except for I hope suffering happens to you. Greatness comes from character, and character isn't formed out of smart people, it's formed out of people who suffered. I wish upon you ample doses of pain and suffering. If you would like to code, for God's sakes, code. If you want to make omelets, make omelets. Don't trigger me, please.
Nvidia CEO 黄仁勋不久前在斯坦福大学经济峰会上面的演讲真的是太精彩了，这是我最近看到的最精彩、最受启发的一次演讲。我们普通人看到的只是眼下的生活和赚钱，黄仁勋看到的是5年、10年甚至更久之后的未来经济、财富、就业和社会问题。我真的忍不住一定要拿出来跟大家分享。演讲时间比较长，全程英文，不过别担心，我帮大家做了翻译、整理和解释的超级精华版，你一定要看完，花时间多看几遍，我都觉得值得，因为太棒了。欢迎来到爱财说，我是 Alex。爱财说频道专门分享学校里边学不到的财商知识，让你财富觉醒、财富自由。欢迎您点赞、订阅、打开小铃铛，选择全部，这样就不会错过爱财说每周更新的精彩影片了。
And so you might as well let the computer go off and grind on just a massive amount of experience we call data, digital experience, human digital experience called data, and grind on it to find the relationships and patterns that, as a result, represents human knowledge. And that miracle happened about a decade and a half ago. We saw it coming, and we took the whole company and we shaped our computer, which was already driving the marginal cost of computing down to zero. And as a result, in the last 10 years, we reduced the cost of computing by 1 million times. The cost of deep learning by 1 million times. And a lot of people said to me, but Jensen, if you reduce the cost of computing your cost by 1 million times, then people buy less of it. And it's exactly the opposite. We saw that if we could reduce the marginal cost of computing down to approximately zero, we might use it to do something insanely amazing. Large language models. To literally extract all of digital human knowledge from the internet and put it into a computer and let it go figure out what the knowledge is. That idea of scraping the entire internet and putting it in one computer and let the computer figure out what the program is an insane concept. But you wouldn't ever consider doing it unless the marginal cost of computing was zero. And so we made that breakthrough. And now we've enabled this new way of doing software. Imagine, for all the people that are still new to artificial intelligence, we've figured out how to use a computer to understand the meaning, not the pattern, but the meaning of almost all digital knowledge. And anything you can digitize, we can understand the meaning. So let me give you an example. Gene sequencing is digitizing genes. But now with large language models, we can go learn the meaning of that gene. Amino acids, we digitized, through mass spec, we digitized amino acids. Now we can understand from the amino acid sequence, without a whole lot of work with cryo-EMs and things like that, we can go figure out what is the structure of the protein and what it does. What is its meaning? We can also do that on a fairly large scale pretty soon. We can understand what's the meaning of a cell. A whole bunch of genes that are connected together. And so this is, from a computer's perspective, no different than there's a whole page of words, and you asked it to, what is the meaning of it? Summarize. What did it say? Summarize it for me. What's the meaning? This is no different than a hard, big, huge, long page of genes. What's the meaning of that? AI, which was enabled by this new form of computing we call accelerated computing that took 3 decades to do, is probably the single greatest invention of the technology industry. Because you've seen a chip before, you imagine there's a chip kind of like this. The chip that John just described weighs 70 pounds. It consists of 35,000 parts. 8 of those parts came from TSMC. That one chip replaces a data center of old CPUs like this into one computer. The savings of that one computer is incredible, and yet it's the most expensive computer the world's ever seen. It's $250,000 per chip. We sell the world's first $250,000 chip. But the system that it replaced, the cables alone cost more than the chip, this H100. The cables of connecting all those old computers. That's the incredible thing that we did. We reinvented computing, and as a result, marginal cost of computing went to zero. That's what I just explained. We took this entire data center and we shrunk it into this one chip. Well, this one chip is really, really great at trying to figure out deep learning. It's really good at this thing called AI. The way that this chip works, it works not just at the chip level and the algorithm level and the data center level. It works together. It doesn't do all of its work by itself. It works as a team. And so you connect a whole bunch of these things together, and it works at, networking is part of it. It weighs a lot, miles and miles of cables, hundreds of miles of cables. And the next one's soon coming is liquid cooled, and it's beautiful in a lot of ways, okay? And it computes at data center scales. And together, what's gonna happen in the next 10 years, say, John, we'll increase the computational capability for deep learning by another 1,000,000 times. And what happens when you do that? Today, we kind of learn, and then we apply it. We go train, inference. We learn, and we apply it. In the future, we'll have continuous learning. We could decide whether whatever that continuous learning result, it will be deployed into the world's applications or not, but the computer will watch videos and new text and from all the interactions that it's just continuously improving itself. The learning process and the training process and the inference process, the training process and the deployment process, application process will just become one. That's exactly what we do. Between now and 7 o'clock in the morning, I'm going to be doing my learning, and then after that, I'll just be doing inference. You're learning and inferencing all the time. And that reinforcement learning loop will be continuous. And that reinforcement learning will be grounded with real world data that is being through interaction, as well as synthetically generated data that we're creating in real time. So this computer will be imagining all the time. Does that make sense? Just as when you're learning, you take pieces of information and you go from first principles, it should work like this, and then we do the simulation, the imagination in our brain, and that future imagined state, in a lot of ways, manifests itself to us as reality. And so your AI computer in the future will kind of do the same. It'll do synthetic data generation, it'll do reinforcement learning, it'll continue to be grounded by real world experiences, it'll imagine some things, it'll test it with real world experience, it'll be grounded by that, and that entire loop is just one giant loop. That's what happens when you can compute for 1,000,000 times cheaper than today. And so as I'm saying this, notice what's at the core of it. When you can drive the marginal cost of computing down to zero, then there are many new ways of doing something you're willing to do. This is no different than I'm willing to go further places because the marginal cost of transportation has gone to zero. I can fly from here to New York relatively cheaply. If it would have taken a month, I'll probably never go. We have more competition than anyone on the planet has competition. Not only do we have competition from competitors, we have competition from our customers.
Yeah,
and I'm the only competitor to a customer, fully knowing they're about to design a chip to replace ours. And I show them not only what my current chip is, I show them what my next chip is, and I'll show them what my chip after that is. And the reason for that is because if you don't make an attempt at explaining why you're good at something, they'll never get a chance to buy your products. And so we're completely open book in working with just about everybody in the industry. What Nvidia is good at is that our architecture, not only does it accelerate algorithms, it's programmable. We're the only accelerator for SQL. SQL came about in the 1960s, IBM, 1970s, in storage computing. I mean, SQL is structured data is as important as it gets. 300 zettabytes of data being created, every couple of years. Most of it is in SQL, structured databases. And so we can accelerate that. We can accelerate quantum physics. We can accelerate Schrödinger's equations. We can accelerate just about fluids, particles, lots and lots of code. And so what Nvidia is good at is the general field of accelerated computing. One of them is generative AI. And so for a data center that wants to have a lot of customers, some of it in financial services, some of it in manufacturing, so on and so forth, in the world of computing, we're a great standard. We're in every single cloud, we're in every single computer company, and so our company's architecture has become a standard, if you will, after some 30 some odd years. And so that's really our advantage. If a customer can do something specifically that's more cost effective, quite frankly, I'm even surprised by that. And the reason for that is this. Remember, our chip is only part. Think of when you see computers these days, it's not a computer like a laptop, it's a computer, it's a data center. And you have to operate it. And so people who buy and sell chips think about the price of chips. People who operate data centers think about the cost of operations. Our time to deployment, our performance, our utilization, our flexibility across all these different applications, in total allows our operations cost, they call it total cost of operations, TCO. Our TCO is so good that even when the competitors' chips are free, it's not cheap enough. And that is our goal, to add so much value that the alternative is not about cost. Of course, that takes a lot of hard work, and we have to keep innovating and things like that, and we don't take anything for granted. But we have a lot of competitors. Yeah. The question on AGI is, what's the definition? In fact, that's kind of the supreme question. If you say, Jensen, AGI is a list of tests. Now, if I gave an AI a lot of math tests and reasoning tests and history tests and biology tests and medical exams and bar exams and you name it, SATs and MCATs and every single test that you can possibly imagine, you make that list of tests and you put it in front of the computer science industry, I'm guessing in 5 years' time, we'll do well on every single one of them. And so if your definition of AGI is that it passes human tests, then I will tell you 5 years. If you asked it to me a little bit differently the way you asked it, that AGI is going to have human intelligence. Well, I'm not exactly sure how to specify all of your intelligence yet. And nobody does, really, and therefore it's hard to achieve as an engineer. Does that make sense? Okay, and so the answer is we're not sure, but we're all endeavoring to make it, better and better. The first role is to understand the meaning of the digital information that we have. We have a whole lot of amino acids. We can now, because of AlphaFold, understand the protein structure of many of them. But the question is now, what is the meaning of that protein? What is the meaning of this protein? What is its function? It would be great, just as you can chat with GPT. In the future, we're going to take a protein, put it into ChatGPT just like PDF. What are you for? What enzymes activate you? What makes you happy? For example, there'll be a whole sequence of genes, and you're going to take and it represents a cell. You're going to put that cell in. What are you for? What do you do? Is to understand the meaning of biology. Does that make sense? If we can understand the meaning of biology, as you guys know, once we understand the meaning of almost any information that it's in the world of computer science, amazing engineers and amazing scientists know exactly what to do with it. But that's the breakthrough. I think one of my great advantages is that I have very low expectations. Most of the Stanford graduates have very high expectations. And you deserve to have high expectations because you came from a great school. You were very successful. You're top of your class. Obviously, you were able to pay for tuition. And then you're graduating from one of the finest institutions on the planet. You're surrounded by other kids that are just incredible. You should have you naturally have very high expectations. People with very high expectations have very low resilience. And unfortunately, resilience matters in success. I don't know how to teach it to you except for I hope suffering happens to you. I was fortunate that I grew up with my parents providing a condition for us to be successful on the one hand, but there were plenty of opportunities for setbacks and suffering. And to this day, I use the phrase pain and suffering inside our company with great glee. And I mean that. Boy, this is going to cause a lot of pain and suffering. And I mean that in a happy way. Because you want to train, you want to refine the character of your company. You want greatness out of them. And greatness is not intelligence, as you know. Greatness comes from character, and character isn't formed out of smart people, it's formed out of people who suffered. For all of you Stanford students, I wish upon you, ample doses of pain and suffering. I'm surrounded by 55 people. My management team, my direct reports is 55 people. I write no reviews for any of them. I give them constant reviews, and they provide the same to me. Many of our executives are paid the same, exactly to the dollar. I don't do one-on-ones with any of them unless they need me. Then I'll drop everything for them. And they never hear me say something to them that is only for them to know. There's not one piece of information that I somehow secretly tell e-staff that I don't tell the rest of the company. And so in that way, our company was designed for agility, for information to flow as quickly as possible, for people to be empowered by what they are able to do, not what they know. And so that's the architecture of our company. I don't remember your question, but I got it. John, no, I got it. And the answer for that is my behavior. How do I celebrate success? How do I celebrate failure? How do I talk about success? How do I talk about setbacks? Every single thing that I'm looking for opportunities to instill every single day. I'm looking for opportunities to keep on instilling the culture of the company and what is important, what's not important, what's the definition of good. How do you compare yourself to good? How do you think about good? How do you think about a journey? How do you think about results? All of that, all day long. The first question is, this is what my wife bought for me, and this is what I'm wearing. And because I do 0% of my own shopping, as soon as she finds something that doesn't make me itch, she's known me since I was 17 years old, and she thinks that everything makes me itch. And the way I say I don't like something is it makes me itch. And so as soon as she finds me something that doesn't make me itch, if you look at my closet, the whole closet is a shirt. Because she doesn't want to shop for me again. This is all she bought me, and this is all I'm wearing. And if I don't like the answer, I can go shopping. Otherwise, I can wear it. And it's good enough for me. I'm horrible at forecasting. But I'm very good at first principle reasoning of the size of the opportunity. And so let me first reason for you. I have no idea how many fabs, but here's the thing that I do know. The way that we do computing today, the information was written by someone, created by someone. It's basically pre-recorded. All the words, all the videos, all the sound, everything that we do is retrieval-based. It was pre-recorded. As I say that, every time you touch on a phone, remember somebody wrote that and stored it somewhere. It was pre-recorded. Okay? Every modality that you know. In the future, because we're going to have AIs, it understands the current circumstance, and because it's tapped into all of the world's latest news and things like it's called retrieval-based. Okay? And it understands your context, meaning it understood why you asked what you're asking about. When you and I ask about the economy, we probably are meaning very different things and for very different context. And based on that, it can generate exactly the right information for you. So in the future, it already understands context, and most of computing will be generative. Today, 100% of content is pre-recorded. If in the future, 100% of content will be generative, the question is, how does that change the shape of computing? How much more networking do we need? More or less of that? Do we need memory of this? And the answer is, we're going to need more fabs. However, remember that we're also improving the algorithms and the processing of it tremendously over time. It's not as if the efficiency of computing is what it is today, and therefore the demand is this much. In the meantime, I'm improving computing by 1 million times every 10 years, while demand is going up by 1 trillion times. And that has to offset each other. Does that make sense? And then there's technology diffusion and so on and so forth. That's just a matter of time. But it doesn't change the fact that one day, all of the computers in the world will be changed, 100%. All of those general purpose computing data centers, 100% of the $1 trillion worth of infrastructure will be completely changed. I said it so poorly that you repeated back poorly. I didn't. If you would like to code, for God's sakes, code. Okay? If you want to make omelets, make omelets. I'm not. Coding is a reasoning process. It's good. Is it going to guarantee you a job? No, not even a little bit. The number of coders in the world surely will continue to be important, and Nvidia needs coders. However, in the future, The way you interact with the computer is not going to be C++ mostly. For some of us, that's true. For some of us, but for you, why program in Python? So weird. In the future, you'll tell the computer what you want. And the computer will you say, hi, I would like you to come up with a build plan with all of the suppliers and bill of material for a forecast that we have for you. And based on all the necessary components necessary, come up with a build plan. Okay? And then if you don't like that, you just write me a Python program that I can modify of that build plan. And so remember, the first time I talk to the computer, I'm just speaking in plain English. The second time, so English, by the way, human, is the best programming language of the future. That because of artificial intelligence, we have closed the technology divide of humanity. Today, about 10 million people are gainfully employed because we know how to program computers, which leaves the other 8 billion behind. That's not true in the future. We all can program computers. Does that make sense? You all know how to prompt a computer to make it do things. Geopolitical risk, we are almost the poster child of geopolitical risk. And the reason for that is because we make a very important instrument for artificial intelligence, we're talking about earlier, is the defining technology of this. The United States has every right to determine that this instrument should be limited to countries that it determines. And so the United States has that right, and they exercise that right. Your question has to do with what is the implication to us. First of all, we just have to understand these policies, and we have to stay agile so that we can comply with the policies, number one. On the one hand, it limits our opportunity in some places, and it opens up opportunities in others. One of the things that has happened in the last, I would say, maybe even 6 to 9 months, is the awakening of every single country, every single society, the awakening that they have to control their own digital intelligence. That India can't outsource its data so that some country transforms that digital data into India's intelligence and imports that intelligence back to India. That awakening, that sovereign AI, that you have to dedicate yourself to control your sovereign AI, your sovereign intelligence, protect your language, protect your culture for your own industries. That awakening, I think, happened in the last 6-9 months.
黄仁勋的演讲给我的启发非常大，未来5到10年，整个世界都会变得不一样。而唯一不变的是，我们每个人都想要变得更富有。如果你想要无成本打造个人自媒体品牌创业赚钱的话，送给大家一个干货直播。我在直播之中分享自己个人品牌的创业经历，如何从0开始年赚100万。有了这些第一桶金，你才有用钱生钱的机会。如果你在 YouTube 上看到本期影片，可以在影片说明栏找到报名链接。如果不是在 YouTube 平台，请您私信我们报名。如果您看到这里了，觉得影片对您有帮助，别忘了订阅频道，顺便帮我点个赞。这里是爱财说，分享学校里边学不到的财商知识，我是 Alex， 我们下次影片见，拜。